So this is 4.2. We're looking at angles again in radians using the unit circle. So radians is the same. Here's our conversions. The new things for 4.2 are arc length and coterminal angle. So arc length is a formula. S equals R times theta, where S is the arc length. So we're finding how long is this arc in radians. So we need to know the radius and then the angle in radians. Okay, so in one of our problems we're going to have to convert to radians to use this formula. Okay, just remember in radians. And then coterminal angle, we've kind of seen this before in our last section. So it's angles that have the same initial side and terminal sides. So if you look at this picture, 45, 405, and negative 315 are all called coterminal because they're all technically the same angle. And we have some formulas, but we know what to do. If we have 405 degrees and we want the angle to be between 0 and 360, we would subtract 360 to get 45. Right? And if we had negative 315 and we add 360, we're going to get 45 again. So it's just how we convert to angles between 0 and 360, and then in radians, how we convert between 0 and 2 pi. So for radians, we add or subtract 2 pi, because that's the full rotation. That's equal to 360 degrees. So for this one, we have pi thirds is our angle, so that's 60 degrees. Let's start with 7 pi thirds. If we subtract 2 pi, we should get pi thirds. The tricky thing with radians is we have to get a common denominator. So I'm going to have to multiply this by 3 and this by 3 to get 7 pi thirds minus 6 pi thirds. Subtract equals out to pi thirds. So those are coterminal, 7 pi thirds and pi thirds. And if we have a negative value, we would add 2 pi. And same thing, 2 pi becomes 6 pi thirds when you get the common denominator. Negative 5 plus 6 is 1 pi, and then the 3 stays.